language instruction means increment register A. Now that means taking whatever is in A and making it one bigger. This here is the machine code representation of the assembly language instruction, and this is what we have to get into the computer's memory in order for this instruction to perform its task. Of course, when we deal in machine code, we usually represent binary patterns by hexadecimal. So 3C is in fact the hexadecimal equivalent of this binary pattern here. So it is reasonable to say that INC A is represented in machine code by 3C, but in full knowledge that 3C is an easy way for humans to remember binary patterns. This is a simplified schematic diagram of a microprocessor system, and we're going to be using this to describe the fetch, decode, execute cycle for the machine code instruction responsible for incrementing the contents of register A. We have already seen that the hexadecimal number 3C represents the instruction that will be responsible for incrementing the contents of register A. Now that has to be put in memory. Now for argument's sake, I'm going to say that this particular code is going to be placed in this memory location here, which has the address AE00. Now for a microprocessor system to work, it needs to know the address of the first instruction it's going to execute in any program. So this address here, AE00, will have to be placed in the program counter, which is this register here. So the program counter will have placed within it the address AE00. We're going to have to make an assumption about something being in register A. So for this demonstration, we're going to say that register A has within it 00. So on the schematic diagram, we can now see that we have the instruction 3C in this location, which has this address AE00, and we can see that the address AE00 has been placed here in the program counter. We can further see that we have made the assumption that register A has stored within it 00, and that H is just there to remind us that we're dealing with hexadecimal. The binary pattern in the program counter is transferred to the memory address register. The program counter is then incremented by 1. Automatically incrementing the program counter is an essential part of the operation of a microprocessing unit. It ensures that the next memory location is pointed to. Now this may have the next instruction, or it may have the operand that needs to be dealt with. The content of the memory address register is transferred onto the address bus, and the control unit sends out 2 low pulses on the control lines. Now I've paused the video at this point so we can look very carefully at what this actually means. Well, the AE00 is the binary pattern responsible for selecting the memory location AE00 in which the opcode 3C is stored. These 2 low pulses, well, they have individual effects. The low pulse on the CS line is responsible for switching the chip on. The low pulse on the read-write line is responsible for ensuring that the location selected is read from. The result is that this particular location is selected and the 3C is going to be read. So it's taken via the data bus to the buffer register, and a copy is then sent to the instruction register. When the opcode is in the instruction register, we regard this as the end of the fetch. That's the end of the fetch part of the fetch, decode, execute cycle. We then enter the decode stage of the fetch, decode, execute cycle, and this is where the electronics works out what 3C actually means. Fed by information from the decoder, the control unit now takes over. It transfers the 00 to the arithmetic and logic unit and asks it to add 1 to it. The 1 is then transferred via the internal data bus and is placed in register A. And that's the execute part of the fetch, decode, execute cycle. And that shows